Recording in progress.
Initially, in this graph, if you see, they have just mentioned, they have just highlighted 2 points. Okay, this one they have mentioned. I told you that there are 4 portions. The first one is this one.
Yeah, I yeah, the first one is like
Hmm.
particles take heat energy and the temperature rises.
Hmm. Yes,
Yeah, and
and
then
what
the
happened at
second
two?
is like
Hmm.
like the liquid particle also takes heat energy and rises and becomes liquid.
Yes. So we can
Yes.
say at 0 degree, what is happening? At 0 degree Celsius,
Uh, Melting.
the ice is melting, right? And then
Yes.
when you
And then
further increase the temperature, what happens?
200 degrees, when we increase it, the water is boiling and like it goes to gas, or we can say steam gas.
Steam form or the gas? The
Yeah,
water, the
gas.
liquid water will convert into gas or water vapors
Yeah,
at the 100
yeah.
degrees Celsius. Yes.
And the fourth point is like the gas is getting hotter.
That is this fifth point when you are
Okay.
increasing further temperature. So it means
Hmm.
their evaporation can happen over here at any point over there, right? We have discussed
Yeah.
that evaporation does not need any specific temperature because evaporation can happen at any temperature. Like for example, you was having water in a pan, maybe in a beaker, and you are heating it. Okay. Initially, the temperature was 35 degree. Then temperature increased to 65 degree. Then it
Hmm.
increased to 95 degree. Then 100 degrees Celsius. It will only
Yeah.
boil at 100 degree, right? But
Hmm.
at any of the temperatures, it can evaporate. Okay. So this was the basic difference between evaporation and boiling.
Hmm.
For evaporation,
Yeah.
you don't need a specific temperature, but for boiling, a specific temperature is needed. Similarly, for melting. For melting, you need a specific temperature that is 0 degrees Celsius, right? For
Yeah.
any species, for any material, the melting point will be fixed, whatever the material will be, and the boiling point will be fixed, okay, for that particular material. It is not zero, it is zero in case of water. I'm just saying, let's talk about the ethanol. If we talk about ethanol, it it will
Hmm.
have a specific melting point and a specific boiling point. At any other temperature, that ethanol cannot boil. Are you clear with this? That boiling point and melting point are some happen at a specific temperature.
Hmm.
Okay. Then now we
Hmm.
will see this graph in further in more details. Like if you see this, the first one, if I highlight this, what they have mentioned, you know what happens when you have ice and you have taken that ice from the refrigerator and you have placed it in the room. What will happen initially? The particles in the ice will take the heat from the room environment, okay,
Yeah.
from the external
Yes.
environment. And when the ice will absorb heat, what will happen? There will be vibration. The vibrations will increase.
Yeah.
Initially, ice is solid, right? So we know the solid in solid, what is the particle arrangement? That they are closely placed like this,
Yeah.
right?
Yes.
So when you have taken this ice outside from the refrigerator and you have placed it in the room, what will happen? This ice will absorb some of the heat from the room because the room temperature is what? Normally room temperature is 25 degrees Celsius, okay? This
Yeah.
is the normal room temperature. So when you have taken the ice, initially ice was at minus 25, right? The temperature of ice was minus 25. If you compare
Hmm.
minus 25 with plus 25, you can get the idea that this is higher temperature, right? Plus 25 degrees higher temperature, higher hot
Yeah.
temperature as compared to minus 25. So what will happen? The ice will absorb heat. Clear?
Hmm.
Ice will absorb
Yeah.
heat. And when ice will
Yeah.
absorb it, what will happen? The particles will vibrate with greater forces. Okay, their vibrations will increase, their speed will increase.
Yeah.
Okay,
Yes.
this is what happening at point one. What is happening at point one? When you have taken the ice from the refrigerator and placed it in the room, what happens in that stage?
Hmm.
I'm asking what will happen
Oh,
If you
okay.
take ice cube,
At the second point,
no, at the first point, I'm asking about the what,
uh,
this, what is happening at the first point.
the first point is where it takes in heat energy and
No,
what's called the
initially
vibration gets
you
faster.
will start from the ice that the initial temperature of the ice is minus 25 degrees Celsius, and you have
Yes.
taken it into the room from the refrigerator into the room. Now you will explain it. What is happening with that ice cube? Or,
The heat energy will make it vibrate faster.
hmm. And from where this heat energy is coming? You will say
From the
the
room,
ice. The ice will
if
absorb
because the
heat
room
energy.
temperature is at 25 degrees.
Yes. So you will say the ice will absorb heat energy, and this heat
Yes.
energy will help to vibrate the particles with faster motion. Okay, their motion will increase, their movement will increase,
Yes.
and the temperature will rise. You know how the temperature is rising? Because now from minus 25, it is
To
going towards
25.
0 degree, right? It is going towards zero
Yes.
degree. This I just gave you general idea about what is the room
Mhm.
temperature, okay? You don't need to
Yeah.
mention this. Just I am telling you
Okay.
how ice is absorbing heat. You must know, you must keep this in mind that when you take ice in the room, the temperature of room is more as compared to the ice. More hotness is there in the room as compared to the ice. If you compare ice, what I'm saying is ice is at minus 25 degrees Celsius, and standard room temperature would we consider in chemistry is 25 degrees Celsius. Okay, so when you place ice in the room, what will happen? The ice temperature was minus 25, so it will absorb heat from the room. Okay, it will absorb heat energy from the room.
Mm-hmm.
And then what will happen? The temperature will rise. The ice temperature will rise. It will, how it will rise? It was initially minus 25 degree, then it will be minus 20 degree, maybe, then minus 15 degree, then minus 10 degree, then minus
Mm-hmm.
5 degree, then 0 degree. Okay, this I have written.
Yes.
So what is happening initially? If you see, if we ignore the negative sign, what is happening? The temperature is decreasing, right? 25 to
Mm-hmm.
20, 15, 10, 5, 0. Temperature is decreasing. But we can't ignore the negative sign because this is with a negative sign. So whenever you have a negative value, always remember this is a mathematics rule that whenever you have a negative value, more the negative value is, the less will be value. More negative means
Mm-hmm.
it is less. Like for example, you have 100 rupees, okay, and then there is a person who have minus 10. It's just an example, minus 10 rupees. So
Mm-hmm.
which one is more, 100 or minus 10?
Hundreds.
Yes, and minus 10. And okay, if I say that a person is minus 1000 rupees, and you have to compare this and this, which one is more, the one or two? Which one is more?
Uh,
It is 100 rupees and it is minus 1000 rupees.
100 rupees.
Yes, 100 rupees is more. So this is what I am saying. The more negative value means it is less value. More negative means it is less value. Okay.
Yes.
So what we are going from negativity, from negative temperature towards positive. You know, 0 degree is a positive, neutral value.
Yeah.
So what you are doing initially from negative to plus, it means you are increasing the temperature. Are you getting this? That temperature is
Yeah.
rising. When you have placed ice in the room, what is happening? The temperature is rising. This is what they have mentioned over here. The temperature
Mm-hmm.
rises. Are you clear with this or should I repeat this?
Yeah. No, no.
Okay, can you
I
explain
got
this? How temperature is rising?
because in the room
Hmm.
they take the heat energy inside the room and then the temperature rises from a negative energy to a positive energy
From a negative temperature value
to
to the 0 degree
positive
Celsius.
and
0 degree is considered a positive value because it is you don't
yeah,
see any like you don't have this value minus zero. This is you will not see
yes.
this in mathematics or chemistry or in any field because zero is a neutral value. Okay, so you are going from negative to a neutral value. You can say This is a neutral
positive
value.
value.
So the temperature is increasing. This is what is
Yes.
happening in the first stage. Okay. Now let's
Yes.
move on to the. I am removing this. If you have to take a screenshot, you can take this, and then I will remove it. Erase this. You can take the screenshot. Are you done?
Yes.
Okay. Now in the second point, what is happening? If you see the second point, what is the second point? That is 0 degree. They have mentioned it at 0 degree. What will happen at 0 degree?
It will rise higher and then
Mm-hmm.
the ice will be melted, like it will
Ice
be
will be,
melting.
yeah, ice will be melted. Okay, how it will be maintained? First thing is they have mentioned this constant line. Okay, this is not like this. This is a constant line like this, right? So it means at 0 degree, the ice remained at 0 degree from this time till this time. Maybe for, you can say for 1 minute. Okay, this time is
Yes.
constant. For 1 minute, it remain in the ice state. Why it is happening? Why 0 degree? Why it melts at 0 degree? The reason is that, when the ice is absorbing heat, what is happening? That heat energy is being used by the particles, right? In this stage, the particles vibration was increased, right? In the first stage, we discussed that vibration was increased. Now, when this point reaches at 0 degree Celsius, we say that at 0 degree Celsius, the heat energy which the ice absorbed was used to break the forces. Okay, the heat energy which ice has taken will be used to break the intermolecular
Forces.
forces. Okay, okay. And when these forces will break, what will happen? The ice will convert into
Liquid.
water, right?
Yeah, water.
So that is why we say at this temperature, at this point, temperature does not rise. Like someone can ask you, like you have ice and you are melting it. So why is this not the case that at 0 degree, why this line is not like this? Like someone can ask you why it is not a straight graph like this. Like you are increasing temperature and you have a solid, then liquid, then gas. This is not the case. Why? Because at 0 degree Celsius, the temperature remain constant for some time. Okay, it will remain 0 degree
Mm.
for maybe 1 minute or 2 minutes. Why it is happening? So that because in this time the heat energy absorbed by the ice is used to break what, the intermolecular forces. Okay, so
Yeah.
this is the time. This is asked in the question that why at 0 degree Celsius there is the temperature is not changing. Why it is a constant for few minutes? Okay, why temperature will not rise in this state? Okay, so they ask you when there is a question like this, that why temperature will not rise at this stage, you will say this is the time, like for 1 minute or 2 minutes, this is the time where the absorbed heat, uh, uh, when the ice absorbed heat, that heat energy is used to break the intermolecular forces. That is why temperature is
Hmm.
not rising in this stage. Okay, that's why
Yeah.
we say the melting point is fixed. Are you getting this? What I'm saying?
Yeah. Yeah.
Okay, so there, here, read this what they have mentioned. But here at 0 degree,
But here at 0 degrees Celsius, the heat energy that is taken is used to overcome the forces holding the particles together in the lattice. The temperature will not rise until all the ice has melted.
hmm. So what they have mentioned here, why temperature is not rising? Because the heat energy is used to overcome the forces. Overcome means to break
overcome.
the, okay, overcome means to break the
Yeah.
forces, okay, to break the intermolecular forces. Clear? Are you clear with this? Why
Yeah.
temperature is not rising? If I ask you in the in the test, so how you will write it? Why
Uh,
temperature will not rise at 0 degrees Celsius?
because it remains constant for one or more minutes
Hmm.
to or
For a few
to
minutes. You can
break
say for a
the
few minutes.
yeah, for a few minutes to break the intermolecular forces by the heat energy that's holding the
Yes.
particles.
Yes. Exactly. That is why in this time region, the temperature will not rise. But afterwards, when the water is
Mm.
melted, now what will happen? When the ice is melted and you have water, what will happen? Further, you will increase the temperature, right? You are increasing from 0 to 25 degree,
Yes.
50, 75, 100 degree. Till this, if you see this line, the third point over here, what will happen?
Yeah.
What will happen according to you?
Uh,
Hmm.
what's it called?
Now you have water, okay? Now you don't have
Yeah.
ice. At 0
Yeah.
degree, you have water,
Yes.
liquid water.
Yeah.
Okay,
And
what
then
will
it
happen?
will like rise more.
Hmm.
Then it will rise more until 100 degrees, so it boils.
I told you a concept of kinetic energy. Recall that concept and then tell me what will happen when you heat the liquid.
The kinetic energy will get faster, and the particles will move faster.
Kinetic energy will increase. Okay, energy does not
Yeah.
fast. We can say kinetic energy will increase.
Yeah. It will
Whenever,
increase.
whenever you are heating something, always remember the particles in that particular thing, they will start movement. They will start a abrupt movement in the beaker. Okay, and when this movement increases,
Mhm.
it happens because their kinetic energy is increased. Okay, always remember this, that
Mhm.
temperature is directly related to kinetic energy. Okay, the more increase in temperature will increase the kinetic energy of the particle. Okay, the more you increase the
Yeah.
temperature, the more you heat the particles, the more they will vibrate. Okay, the more they will vibrate in different
Mhm.
directions. Clear?
Mhm.
So this is
Yes.
what will happen here. You have liquid water, and you are heating it. You are constantly providing temperature until 100 degrees Celsius. Till this point, what will happen? The heat energy, the particles, what will happen there? Kinetic energy will increase actually. Okay, the particles in the liquid take in heat energy and slide past each other. What is meant by slide past each other? Like they will vibrate. Okay, they will vibrate and they will slide past each other at a faster rate and the temperature will rise. Clear? Like you can write in this, in the third question,
Yes.
you can write about this, which I have mentioned, that in the third point, what is happening when you are increasing the temperature, the kinetic energy of the liquid is increasing. Okay. And when the kinetic energy increases, what happens? The particles move at a faster speed. Particles motion will increase. Clear? You can mention this or you can mention this one. Okay, both reasons are correct. If the particles in the liquid take in heat energy and
Hello.
slide past, yeah, can you hear me?
Hello.
What happened?
Hello. Hello. Hello.
Yes, am I audible? I was asking you, in the liquid
Hello.
will absorb
Recording in
heat and,
progress.
sorry, can
What?
you, I'm
Yes.
saying at point 3, when you see at point 3, this one, you have two reasons. You can say that at point 3, the liquid, the temperature of the liquid is rising, and due to this rise in
Hmm.
temperature, the kinetic energy is increasing. Okay, and
Yeah.
when the kinetic energy increases, the particles movement increases. Okay, the particles motion increases. So at
Yeah,
point 3, what is happening? Their movement is increasing. The particles are moving
yeah,
faster. Okay, they will slide past each other at a faster rate. Clear? Are you clear with
yeah.
what is happening at the point 3?
That the temperature
Hmm.
rises,
Temperature will
but because
rise.
the
Hmm.
kinetic energy
No, because
rises as well.
yeah, because of temperature, kinetic energy is rising. You will not say that because of kinetic energy, temperature is rising. You will say
Yeah,
by increasing temperature. Yeah, because you see what we are doing. We are increasing temperature from 0 degree. You are going to 25 degree, then 50 degree, then 75 degree, then 100 degree.
yeah,
So basically, you are increasing the temperature, and when you are increasing the temperature,
yes,
the kinetic energy will ultimately increase. The kinetic energy of the particles will increase, and when the kinetic energy will increase, the motion in the particles will increase. Okay, the movement in the particles will increase. Clear? Are you clear with the point number 3?
yes.
You can take the screenshot, then I will erase this
Okay,
for the point fourth explanation.
okay then.
Okay. Now in the point number 4, if we see this, what will happen at 100 degrees Celsius? Just like 0 degree, they have examiner asked the question. It is a very common question in the most repeated question in the CAIs, that why at 100 degrees Celsius the temperature will not rise for a few minutes. If you see from this point, from maybe from 2.5 minute till 7.5 minutes. If you see from 2.5 till 7, like for 5 minutes, approximately for 5 minutes, the temperature remain 100 degrees Celsius. It is not further increasing. Why is it so? They can ask you. Okay. So just like the
Mhm.
reasoning which we discussed over here, that at why at 0 degree temperature is not rising. Similarly, there is the reasoning over here that why temperature will not rise at 100 degree. So what will happen at 100 degree? The particles, what they were doing when they were in liquid state, their kinetic energy was increased and their vibrations were increased. Okay, but in liquid there are some intermolecular interactions as well. We have discussed in the first class that in the solid there are strong intermolecular interactions, then in liquid there are intermolecular interactions present also, right?
Yeah, yes.
So in liquid there are intermolecular forces as well. Keep this in mind. Okay, they have
Mhm.
intermolecular forces as well. So what will happen at 100 degrees Celsius? The temperature will be used to break these intermolecular forces, just like over here at 0 degree. We discussed at 0 degree what was happening. The temperature, the heat energy provided by the rise in temperature will
Right.
use to break the intermolecular forces, and then ice will convert into water, right? Similarly,
Yeah,
when you have liquid
yeah.
water, when you have liquid and at 100 degrees Celsius, what will happen? The heat energy will be used to break what? To break the intermolecular forces present in the liquid, right?
Intermolecular forces.
Of liquid.
Yeah.
When this will be broken down, what will be formed? The gas will form, right?
Steam. Yeah.
Because in the gas there are you can say very intermolecular forces are not there. They are not observable in the gases. So
Yeah.
initially at 0 degree Celsius, you have 2 points where the temperature is not changing for few minutes. At 0 degree and 100 degree. So at 0 degree, why temperature is not changing for a few
Yeah.
minutes? You will suggest that at 0 degree, the temperature you have provided will be used to break the intermolecular forces. Okay, then that temperature will provide heat
Yeah.
energy to break the intermolecular forces, and thus the ice will convert into liquid water. Clear?
Yeah.
Similarly, at
Yes.
100 degrees Celsius, the heat energy that is taken by the liquid is used to overcome the intermolecular forces. Okay, overcome means to break the intermolecular
Mm.
forces between the
Break
particles.
into
Yes,
yes.
and at this time the temperature will not rise. Temperature will not rise, and the liquid will convert into gas. Clear? Read this line from here till
Yeah.
this. But here at 100 degree,
But here at 100 degrees, this heat energy that is taken in is used to overcome the forces between the particles. The temperature will not rise again until the water has turned into gas.
Yes. Are you clear with this?
Yes.
Okay, I write the questions. Now you have to tell me, question number one, why at 0 degrees Celsius the temperature is not rising? Why at 0 degrees
Okay.
Celsius?
Done.
Then second question, what is happening when you are melting, when you are providing temperature to the liquid? When you are increasing, okay, you can change the question. What is happening when you are increasing the temperature of a liquid?
Okay.
Third question, what will happen at 100 degrees Celsius?
So what is hap so what is happening when you change the what?
When you are increasing the temperature of the liquid,
Okay.
when you are increasing the temperature of the liquid, like this state, I am asking about this state, this one, because you are increasing the temperature of the liquid, right, from 0 to 100 degrees.
About what?
I'm saying the
Yeah.
question number two, the question
Yes.
number two I have asked is about this point, when you are increasing the temperature from 0 to 100 degrees. Now, third question is, what is
Yes.
happening at 100 degrees Celsius? What is happening at 100 degree Celsius?
What is happening at? Yeah.
Mhm.
Okay.
Okay, now what further if you see you have gas, right? The liquid is converted into gas, and further what will happen when you increase the temperature of the gas, the particles movement will increase and the temperature will keep rising. Okay, the motion of the gas will increase, and some of the particles may evaporate, and it will keep temperature will keep rising. Clear? When you go beyond 100 degrees Celsius. Now you have 2 points over here. They have mentioned a heating curve shows how the temperature of a substance changes as you heat it up. Okay, you see how the temperature was changing when you heat it up, like when you were having ice and you converted it into liquid. What was happening? Temperature was increasing or
I can
decreasing?
your screen. Mm-hmm.
Wait a minute.
In
Is this visible? Is my screen visible?
Yeah, yeah, now it's visible.
Okay. I am saying that if you see this, they have mentioned over here that this graph is called a heating curve. Okay. A heating curve shows how the temperature of a substance changes as you heat it up. Now, what they have mentioned that temperature of a substance changes when you heat something, right? When you heat that particular thing. Are you, do you agree with this statement? That the
Oh,
temperature of a substance changes when you heat it up. This one.
yes.
Okay. So can you justify this with an example? Like you have ice and you have liquid. What is happening with the temperature when you are going from ice towards liquid? The temperature is increasing or decreasing?
Freezing to break the intermolecular forces
That I'm asking that
by heat energy.
temperature is increasing or decreasing?
Increasing
How?
because it goes from minus 25 to 0 degrees,
Yes, minus 25
and
to
then
0 degree. Yes. And when we talk about from liquid to gas, what will happen?
25 degrees to 100 degrees.
Yeah, from 0 degree to you can say it can goes to 100
Yeah.
degree. The liquid will boil first. Okay, there will be boiling of the
Mm,
liquid at 100 degree and it can go further. The temperature can further increase.
yes.
Clear? So yeah, this
Mhm.
this statement is correct. that the temperature changes when you change the state. Okay, when you are changing the state.
Yes.
Okay, not the actual. The time is a measure of how much heat energy has been added. Okay, this time was telling you how much heat was added. Okay, now they have mentioned 2 points that the temperature remain constant while water changes the state. What is this? Temperature remain constant while water changes the state. What they are saying? Think about it.
Uh,
Hmm.
like at 0 degrees, it remains
Yes,
constant.
exactly.
Yeah.
Because at 0 degree, what is happening? The ice is converting
It
into
remains
liquid, right?
liquid.
So this is the temperature. This temperature is constant temperature, right? 0 degree is constant temperature.
Yes.
So at 0 degree, the state is changing. The water was initially in the solid state. Now its state is changed into liquid. Okay, liquid water. So this
Mhm.
statement is correct. Similarly, these temperature are its melting and boiling point. Like for example, at 100 degree, if we see what is happening, 100 degree is also constant temperature. So at this, the liquid is converting into gas. Clear?
Yes.
So the first point is justified. We agree with the first statement. The second statement is that these temperatures are its melting point and boiling point. We agree with this, right? This is known as
Yeah.
the melting point, and this is known as the boiling point. Clear?
Boiling point. Yeah.
Okay. Then they have mentioned, yeah, cooling curve we will do tomorrow. Can you now tell me firstly the what information we are getting from the heating curve? Okay, write this question. What information we get from the heating curve of the water?
Done.
Okay. Now can you explain what information we get from heating curve? Like, can you justify
Uh,
these
it,
statements, these all bold statements?
okay, so a heating curve shows us like how the temperature increases when you heat it up, and
How the temperature changes,
it
okay?
will,
You cannot
yeah,
try,
changes,
you will not try how the temperature increases. Obviously,
increase.
in this temperature is increasing, but there will be many other substances in which temperature will not
It will
increase.
decrease as
It will
well.
decrease,
Yeah,
right? There will be some
yeah.
substances as well. So you can say the temperature is
So
changing as you are heating that
temperature
substance.
is, yeah, temperature is changing as you're heating the substance. So
Now you can
it
mention
go,
the example of water and explain it.
like ice to liquid.
Hmm. Like for example,
So
if they
like
ask you this for the 2 marks, so you will not just
mm,
write the statement, you will write the answer with an example. Like you will mention, for example, you have ice, and the ice it
ice
is
is,
solid, right? And
yeah,
when you heat the ice, what will happen? It will convert into liquid,
yeah,
and the temperature will rise. So this is the example,
yeah.
right? Because they are
Mhm,
saying temperature of the substance is changing. Clear?
mhm.
Now, tell me the example again from solid to liquid
It,
and from liquid to gas.
so it goes from solid to liquid when temperature rises, and what's for liquid to solid, it will also what's it called? It will also increase, and then it will boil boil when it goes to 100 degrees.
Yes. So it means temperature is increasing. Temperature is
Yeah,
rising in this case. Now the
yeah.
second statement, they are saying temperature remain constant while water changes the state. Is this true?
Yes.
Why?
Because as it goes from at 0 degrees, it remains constant for a few minutes, so it can break the intermolecular forces
Hmm.
to convert it into from solid to liquid, ice to liquid.
Right. There. Now, can you explain this graph from the? I am mentioning these points. This is point number one, two, three, 4, and 5. What is happening at point
Okay,
1?
so do I just okay point one? It's going from what's it called? It's, minus 25 degrees to 0 degrees. It's like
What's point? Ice.
heating up. Heat
Hmm.
ice is gaining heat energy to break the
Hmm.
solid particles.
No, at this stage, it is not breaking. Okay. In this
Oh,
first
okay,
stage, the breaking will just happen at 0 degree, right? We say that at 0 degree,
okay,
why temperature will not rise because at this time, the heat energy which ice has absorbed already will be used to break the intermolecular forces. Okay. So
hmm.
before that, the breaking will not happen. At point one, breaking is not happening. What is happening? Just the
It on
ice is
the
absorbing.
temperature rises.
Yeah,
So like it absorbs heat energy and temperature rises to 0 degrees. And at 0 degrees, it remains constant for a few minutes to break the intermolecular forces to break the intermolecular forces to
so
make
then,
it from
hmm,
solid
hmm,
to liquid.
hmm.
Uh, And then the liquid particles take heat energy as well, and then it rises, and then the temperature rises.
Okay, firstly we
And when if the
mentioned
temperature,
and when the temperature, now when you have liquid water, now you are increasing its temperature. So
yeah,
by increasing this temperature, the heat energy is increased in them. Okay, the heat energy will increase and the kinetic energy will increase. And when the kinetic energy will
yeah,
increase, what will happen?
the particles will move faster.
Yes, their motion will increase, their movement will increase. Okay, at point 4, what will
Yeah,
happen?
and then at point four, it will go to 100 degrees, and the boiling will start, and it will go from liquid to gas
Why? What is the reason?
because it breaks the